Hi, I'm Ellie Burton, and today I'll be discussing my work on enhancing sex trafficking detection through graph-based analysis of online sex ads. So just a little bit of background, sex trafficking is the use of force, coercion, or fraud to compel an individual to provide sexual commercial sex acts against their will. This is a major problem in the United States and worldwide, with an average or an estimated 6.3 million individuals being sex trafficked around the globe. This is also a problem in our own community, with the Global Slavery Index estimating over 6,000 individuals being trafficked in the state of Alabama. The UN Crime Prevention Agency warns that for over a decade, online sex ads have been the main tactic used by traffickers to solicit buyers for commercial sex. So our initiative uses data from these sex ad websites to help identify potential victims and provide actionable intelligence to law enforcement and nonprofit partners to help identify these victims. So as I mentioned, we collect data from these websites with 24/7 data collection. We have 12 active sites that we scrape from, with over 250 million ads dating back to 2019. On an average day, we'll collect 110,000 unique ads, as well as 300,000 images. So let's take a deeper look into what these ads look like. Every ad will have a series of pictures associated with it, as well as a phone number for contact information and a text associated with it. We also have the location that it's posted to. So when we have all these ads that were being scraped, we can represent them in a graph data structure format. This allows us to see the connection between different data artifacts, being that they're used in the same post. So in this example, we have 3 different posts constructed into 3 graphs with edges linking together data points. When we bring down these posts, if we see an artifact that we've already seen before, for example, the same image in 2 posts, we can connect those together and assume that that links together those ads as a possible individual. This helps us to build up possible representations of individuals on these sites to provide the best information for law enforcement. Creating these components that we can link to potential victims and give a data product to the police that gives them a lot of information in a more easily accessible and readable format to help in making their efforts as intelligible as they can and helping to guide their efforts. We run into a main problem in this algorithm called a giant component, where a large amount of the data becomes interconnected through errors, links, and noisy data. This is around 40% of our nodes, and this is a lot of individuals being tied up together that we can't isolate and provide actionable insights on. So this is a major problem in providing the best information that we can to law enforcement. This is caused by a variety of reasons, including common data points like the text "available now," "hey," or common images like logos. This can also be caused by stolen images. If an individual wants to post a more explicit image but might not want to post it of themselves, they may find someone else that looks similar to them, steal that image, and that would link up those 2 individuals who are completely unrelated. Scam ads can also introduce a lot of noise into this data set and make it harder to isolate these potential individuals. So going back to this data set that we were looking at earlier, we have these unweighted, undirected, just binary linkages between data points. We can help to look at the significance of these weighted or these edges by weighting them and seeing a sort of confidence score on the connection. So looking at this example, we might have 2 posts, post A and B. Post A is seen 100 times and post B is seen 20 times, but they both include the same image. So this image is seen 10 of the 100 times with post A, but it's seen in all 20 instances of post B. So we can calculate weights of how often this connection is seen versus how often we see the data point in the total data set, and that allows us to calculate a sort of confidence that they're connected. If we set an edge threshold, for example, 0.7, we can eliminate some of the edges and see only the strongest connection is remaining. So in this example, we go from 1 component that might be noisy or have inaccurate information to 2 that might better represent the actual individuals behind these posts. So this is the main method we can use in weighting the edges to break down the giant component, but evaluating the efficacy of it is problematic. We don't have a large data set that helps us to see a robust amount of ads and what the individuals they're linked to in reality. So our solution is to compare it with benchmark nodes or components that aren't linked up in the giant component originally. So we're looking to see, do these new components that we've decomposed out of the giant component fit our heuristics of what the components should look like in the first place? So this is going to be by 4 metrics. Firstly, the giant component reduction in and of itself. So how well does a certain threshold do at reducing the giant component? And then at each of those threshold levels, what does the average component look like that's being decomposed? Firstly, by component size, so how big are they compared to the ones that we should expect? The spatial similarity, so are they moving around a lot of different states, or are they mainly in one? And finally, text similarity, so how similar is the text that we see in a given component compared to what we would expect? These final 3 metrics we're going to measure using something called Earth Mover's Distance, which is just a measure of how similar 2 distributions are. So a smaller distribution or a smaller Earth Mover's Distance would indicate that the distributions are more similar, and thus we can say that the components look more like what we would expect, and a smaller value would be better. So firstly, we can see that as we increase the edge weight threshold, so as we bump that up and up, we receive a larger decrease in the giant component, which is exactly what we would expect and the main aim of this method. Looking at how those components now look, we can see that we also see a decrease in that Earth Mover's Distance, so we're looking closer and closer to what we want the components to look like. In all of these graphs, we can see a cutoff around 0.5, where we're seeing an optimal level of reducing the giant component and also optimal levels of likeness with what we expect without removing more nodes than are necessary. So these results show some really promising ideas with decomposing it, but still retaining what we would expect the graph to look like. This can be combined with other metrics and other methods in conjunction to even better simulate what we should expect from the resulting components, and this is just one part of a larger puzzle. So in conclusion, this research is about more than just the computational efforts behind it. It's about the real-world impact that we can have on our community. This initiative has helped give actionable intelligence to law enforcement and led to 275 arrests for soliciting, 64 arrests for traveling to meet a minor, and over 60 potential victims, which is a limited estimate due to feedback from law enforcement. Thank you, and do you have any questions?
So your goal is to reduce the giant component. What if someone on the dark side, like a cartel or someone, wanted to do all this web scraping themselves, build up all these networks, and then just purposely start overwhelming and increasing the GC just to kind of thwart your attempts? How would you stop something like that? Or how would you be able to detect that someone's out there on the side kind of purposely overwhelming you?
Yeah, so I think that looking into like purposeful scam or like noise being injected into the data set is something we already have to deal with a lot due to a lot of scam ads. There's a lot of people that know that I can tell someone, okay, you need to send me this amount of money as a deposit, and then I'll never respond to them again, and they have no recourse because it's an illegal activity that they're trying to participate in. So there is already a lot of scam that we are able to filter out through these methods, but specifically like a targeted attack, I think would be something that we would have to deal with as it happened and maybe adjust as we see that coming in through the data.
Have you dealt with any ethical or legal considerations regarding collecting data like this or using this information?
Yeah, so in partnership with law enforcement, we do have a lot of obviously sensitive data that's being communicated back and forth. We don't have as many legal implications because we're not pointing out like trafficking, we're not labeling it trafficking. We're just giving them the information in a more easily accessible and readable format and helping to link together people they might not realize are the same person originally. But there's obviously a lot of sensitivity with that data that we do have to deal with.
Can you provide more insights into how your findings are translated into actionable strategies for both law enforcement and nonprofits?
Yeah, so this data product that I showed you is really, really effective in helping nonprofits specifically, as well as law enforcement, not have to hand sift through these websites, which could be like uncomfortable or just less, take more time than being able to see a kind of concise and efficiently prepared data product. This especially helps with being able to kind of censor different information for different law enforcement or nonprofit entities who may not want to be seeing explicit images or may just want a list of phone numbers, something like that.
So you mentioned the data product you provide to law enforcement. Do you ever receive any data back from them that can help like further develop your models?
Yeah, so right now we receive pretty limited data in response, but we're currently working on a web portal that will allow us to have a more streamlined exchange of information with law enforcement, where they'll be able to update based on specific component numbers that we provide them and get back information on potential trafficking victims, or if our groupings are correct, stuff like that, to hopefully be able to feed back into our process and allow us to have better and more efficient algorithms.